What if we're not alone? What if, somewhere in the cold dark between stars, another civilization is asking the same question we are right now? For as long as humans have looked up, we've wondered whether Earth is unique or just one oasis among many. Today, science is closer than ever to answering one of humanity's oldest mysteries. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're diving into the science, the evidence, and the possibilities behind the search for extraterrestrial life, from microscopic organisms hiding under Martian ice to advanced civilizations that might be broadcasting across the galaxy. Life, as far as we know, is fragile. It needs chemistry, stability, and time. Yet the more we study the universe, the more it seems filled with places that could support life, not just billions, but trillions of them. So the real question may no longer be, is there life out there? But how could the universe possibly be empty? To understand where life might exist, we first need to understand what life requires. On Earth, the recipe begins with three things: liquid water, organic molecules, and a stable source of energy. These ingredients emerged surprisingly quickly in Earth's early history, forming oceans, building complex chemistry, and eventually giving rise to the first living cells. And here's the astonishing part: these same ingredients appear to be everywhere. Water isn't rare. It's abundant in comets, moons, exoplanets, and interstellar clouds. Organic molecules, the carbon-based foundations of life, have been found drifting in nebulae, frozen in meteorites, and forming naturally on distant worlds we've never even visited. Even energy, whether from sunlight, geothermal heat, or chemical reactions, is scattered across the cosmos. If the ingredients for life are universal, then the possibility of life itself becomes far more realistic. Let's begin with our closest neighbor, Mars. For decades, Mars was imagined as a planet with canals and civilizations, a fantasy born from blurry telescopes and hopeful imagination. But modern science paints a different, yet equally fascinating picture. Mars was once warm, wet, and Earth-like, complete with rivers, lakes, and possibly even a global ocean. NASA's rovers have discovered minerals that only form in water, ancient riverbeds carved into the landscape, and chemical signatures that hint at past habitability. If life ever evolved on Mars, even as microbes, traces of it might still be buried beneath the frozen soil or trapped in subsurface ice. And if life can survive there, it suggests something profound. Life doesn't need a perfect world. It just needs opportunity. Beyond Mars lies a realm that may be even more promising: the icy moons of the outer solar system. Take Europa, one of Jupiter's moons. Beneath its glittering shell of ice lies a vast global ocean, more water than all of Earth's oceans combined. That ocean is heated not by sunlight, but by tidal forces from Jupiter's immense gravity, creating a dynamic environment where liquid water, minerals, and energy mix. Essentially, Europa has all the conditions Earth's deep-sea vents have, places where, on our own planet, life thrives in complete darkness. Then there's Enceladus, a small moon of Saturn that seems impossibly active. It shoots plumes of water vapor, ice, and organic molecules from cracks in its surface. These plumes are so powerful they escape into space, and spacecraft like Cassini have flown right through them. Analysis revealed something extraordinary: the chemistry inside. Enceladus resembles the chemistry inside Earth's oceans, where life first emerged. Warm water, nutrients, and complex molecules, the building blocks of biology, are all there. If microbial life exists anywhere close to home, Enceladus may be one of the best candidates. But the search doesn't stop within our solar system. Over the last decade, astronomers have discovered thousands of exoplanets, worlds orbiting distant stars. Some are rocky like Earth. Some have oceans deeper than anything on our planet. Some exist in the Goldilocks zone, where temperatures are just right for liquid water. Others are super Earths, planets larger and potentially more hospitable than our own. And a handful may be water worlds, covered entirely by global oceans. Even more compelling is the discovery of exoplanet atmospheres. Using telescopes like James Webb, Scientists can now analyze the light passing through distant planets' atmospheres and detect gases like water vapor, methane, and carbon dioxide. These molecules don't prove life, but they tell us the chemistry of these worlds is dynamic and potentially habitable. And one day, we may detect a biosignature, a combination of gases that on Earth could only be created by living organisms. There's also the possibility of technosignature signs of technology from advanced civilizations. These could include unusual radio signals, artificial chemicals, megastructures blocking starlight, or patterns that don't occur naturally. The famous WOW signal detected in 1977 is still unexplained, a 72-second burst of radio energy that matched what scientists expected from an intelligent transmitter. It never repeated, and no one knows what caused it. But SETI, the search for extraterrestrial intelligence, listens every day. Giant radio telescopes sweep the sky for signals that stand out from natural cosmic noise. If an advanced civilization exists and is attempting to communicate, even from thousands of light years away, we might hear them. But silence doesn't mean emptiness. A civilization may be too far, too young, too old, or simply not broadcasting. Here's the strange paradox. Mathematically, the universe should be overflowing with life. There are roughly 100 billion stars in our galaxy and about 2 trillion galaxies in the observable universe. If even a tiny fraction of stars have planets like Earth, there should be countless worlds capable of supporting biology. So, where is everyone? This question is known as the Fermi paradox. Maybe intelligent life is incredibly rare. Maybe civilizations rise and fall before they can explore the stars. Maybe they stay quiet to avoid being found. Or maybe the universe is full of life, but we have only just begun listening. Another possibility, life might not be rare at all, but intelligence is. On Earth, for nearly 4 billion years, life remains simple. Single cells, microbes, small organisms. Complex, intelligent beings like humans emerged only recently. If intelligence is a fragile or unlikely outcome, then the universe may be filled with life that we cannot communicate with, vast oceans of microbes, forests of alien plants or animal-like creatures evolving on distant worlds. Yet the idea that we might one day discover even microbial life elsewhere would be revolutionary. It would mean biology is not a miracle confined to Earth. It is a natural consequence of physics and chemistry, a universal phenomenon. And if the universe creates simple life easily, then the path to complex life and eventually intelligence may only be a matter of time. Some civilizations could be millions of years older than ours, with technology we can't even imagine. Others may be just beginning, evolving under alien skies, unaware that we exist. So where does this leave us? The search for extraterrestrial life is not just about finding aliens. It's about understanding ourselves. It asks, are we unique? Are we early? Are we late? Or are we just one thread in a vast cosmic tapestry? If we discover life beyond Earth, even something microscopic, it will reshape biology, philosophy, and our understanding of what it means to be alive. It would mean that the universe is not empty, it is fertile. And if we someday detect intelligent life, it will be the most profound moment in human history. It wouldn't diminish our existence, it would expand it. It would mean that across unimaginable distances, the cosmos has given rise to other minds, other beings capable of wonder, curiosity, and dreams. Before we close, here's a thought to carry with you. The universe is too big for us to be alone and too beautiful for life to be rare. This is Mattermosaic, piecing together the universe, one discovery at a time. If this video sparked your curiosity, leave a like, share it with someone who loves science, and tell us what you'd like to explore next. Subscribe for more weekly journeys through the fabric of reality.